Okay. Um, so for the tutoring on my part, it's about the volume of the solid of revolution. So, um, for the outline here is the first one is the volume by Dix and Washer method, and the second one is the volume by Cylindrical shell method. So for the summarize of the concept of the volume by Dix and virtual method is that let's recall when we have a pyramid at the high school, we say that the volume of the pyramid is just a base area, right? Times by height of it. So we try to extend this concept to be the concept of the volume of any shape. So if we start by the volume like this may not and prism anymore, right? But it's kind of um any general shape that you would like to find its volume. So we start by try to section the volume like this. And then we define the area function to be AX. So for the particular xi star here, we have the area of the section at the point xi star as the axi star. So if we try to find the volume of a small slice, this slice, if we try to find the volume of this slice, it should be axi star, which is the area of the section, and then times by the thickness. The thickness over here is actually the delta x. So this is a volume of one piece of this. And then we try to select for the interval a to for the interval AB, so that we get the volume to be the summation of the n piece of the slide. So I would say I cut the slide to be n piece. So this should be summation from I equal to 1 to n. So next we try to reduce the error of the volume over here. So we take the limit of n to be infinity. So this one is the volume of the shape. So the limit of n tend to infinity. Combined with the summation, we obtain the integral. So the formula of the volume for the given shape, it should be the integral of ax dx, and then start by point A to point B. And this one is the concept of the section to find the volume of the shape in the general. So when we restrict ourselves to find the volume of the particular area, and then we rotate the particular area about some axis, we obtain the particular formula, which is called Dix method and the washer method. For the Dix method, it's like you try to cut the section, and the section is actually the circle. So if we have like a function over here, and then we try to rotate about x-axis like this, so you may obtain the volume look like this. So you can see that the section is actually the circle, right, with the radius equal to the function. So the functions here, I would say it should be y equal to fx, right? So the particular section is only the circle with the base area function at pi equal to fx and then square. And you see this at radius 1. So we take the integral of the pi fx square and then take the boundary to be from A to B, like this. So we got the rotation about x-axis of this method. And similar to the rotation about y-axis, you can see that the radius of the x-axis is actually the function of y. So this should be the value of the boundary of y. But from the washer, it's kind of more advanced. We take the area of the particular two function, and then the area of the rotation is kind of between them. So when we rotate, instead of getting the circle, we obtain the ring. So when we're speaking about the ring, it should be pi. The area section should be pi times by the big radius square and minus the small radius square. So actually, it's just the function of the above one. We say y equal to x, and then minus the function of the inner radius, the small one. So the formula should be integral of the pi times by the above above function and then square and then minus the inner function, which is the lower one and then square. And this is just the area of the particular ring. So okay, let me work with the example. Okay, the first example, we try to find the volume of the area that bound by the function y equal to square root x from 0 to 1. And then we will use this method. So this should be the volume of the integral. And then we try to use the thickness at the x, right? So we put dx over here to remind that we will give the function of x, right, like this, right here. So we start by pi r square, and we try to find the r, which is the function y equal to square root x. So our r is square root x, right? And then we put on the formula pi r square, which is pi, and then square root x square. And then we use the boundary 0 to 1 over here. And that's all. And this one is just a volume of the form of the integral where your area of the section is at a circle. So next we just compute the integral directly. So we had x squared over here, and then 1 over 3 x cubed, and then we sub x to be 1 minus 0. So the answer should be pi over 3. Okay. Okay. Is there any question? Oh, seems like I do integral wrong here. Sorry. It should be x squared, right? Sorry. Okay, it should be x squared over 2, and then over here is 1 over 2. Okay. For the next one, we try to rotate with the y-axis. So our this is look like the area with pink end, but it's still a circle. So we just remind ourselves to do the integral over y variable like this, and then we try to put pi and then find the function of the radius in terms of y. So the given function is y equal to x cubed, and we try to change this at the function of y. So we had x equal to the cube root of y over here. So this is our radius, y cube, oh sorry, cube root of y, and then square. So actually we just put the function of y as a radius, right? So the section should be pi r square, where the pi is the cube root of y, and that's all. And then we put the boundary of integral to be 0 to 8. Okay. And next we just calculate this integral directly. So we had pi and then 0, 8, and then I will change the form to be 1 over 3 square. So it should be pi of the 1, 2 over 3 dy, and then y over 5 over 3, 3 over 5. And we set y to be 8. So it should be 2 cube over 5 over 3, and then minus 0. So from here, we cancel 3, and then we get, this one should be 5. 3 over 5, and then 2 over 5. This is 32. And then the answer should be 96 over 5 pi. The main is that you just try to think about what is your radius and what is your particular axis of rotation. Okay, so next we'll move to the washer method. Washer method is the kind of quite similar idea with the Dix method, but instead of obtain the circle section, you get the ring section instead. So for the example 3, the region R is enclosed by the y equal to x, which is this line, and then the parabola y equal to the x squared, which is this line. So the first thing that you may have to find is that the intersection point to be your boundary of the integral. So I may start with find the intersection point, but you may see over here, right? Because I put the picture to you to see clearly, but when you're Excel, you don't have any picture, so you have to find the intersection point by yourself. So firstly, I may focus what the point, what the value that I want to find. Like over here, we have to rotate about x-axis, right? So our section should be the ring like this, and the thickness is the x variable. So our integral should be respect the x variable. So when you find the intersection point, you may no need to find the value of y, only the value of x. So I may find the value of x by bring these two equations to be equal. So x squared minus x equal to 0, and then x times by x minus 1 equal to 0, and then we obtain the value of x, which is 0 and 1. So we will know that the boundary of the integral should be 0 to 1. 0 to 1. then we try to find the area section, which is pi, and then the big radius square minus the small radius square. So the big square, sorry, so the big radius should be over here. The outer radius should be the function of the linear, right? So we need x over here. And then the inner radius should be the parabola value, so it should be x squared. So we put x square here, which is the bigger radius square, and then minus the inner radius square. And the inner radius square is x square and then square. Okay, so we're done with setting the integral. So next we have to find like a basic integral one. So this should be x squared minus x power 4 and then dx. And then 1 over 3 x cubed, 1 over 5 x power 5, 0 to 1. And then 1 over 3 minus 1 over 5, and then 2 over 15 pi. Okay. For the next example, it might be complicated a little bit more than the last example because we change the axis of the rotation to be another line, not just x axis or y axis. For here, we change the x axis to be the axis of rotation to be y equal to. So we have to really be careful about what is the radius of the inner and outer. So we will integrate respect with the variable of x due to the thickness here is still the delta x, right? So we try to find the volume that respect to the variable x. So the boundary should be the same, 0 to 1. And then for the radius, you have to deal with the line y equal to 2. So the inner radius should be 2 and then minus x. Don't forget that 2 minus x comes from when you have y equal to 2 over here, and you need the inner, which is the length of the green segment, right? And the green segment over here, this is x, and this one is 2 minus x. Oh, sorry, this one is x, and this one is 2, right? So the green segment over here is of the length 2 minus x. So for the outer radius, it's like, I should be right here. Okay, and this one is x squared, right? But this one is 2, this one is x squared. So the orange should be 2 minus x squared. So the outer radius should be 2 minus x squared, the orange one, and then square. And then minus the inner radius square, which is 2 minus x squared. Okay. So next we just do a simple calculation on the integral. So I may go quick for this part. no, 4x squared log x minus 4, and then 4x x squared dx. This one should be cancelled. Okay. And the remaining is just minus 5x squared plus 4x, right? Minus x dx. Sorry, this one should be plus. Okay. Okay. And then with the symbol calculation, we obtain minus 5 3 to x squared 1x 5 0 to 1, and then plus 2 plus 1 over 5, which is over 15, and then pi. Okay. Is there any question for the Dix or virtual method? Okay. So next, we move to the exercise. When you do your exam, you may not have the graph, the example I show you, so you have to like sketch the function by yourself. For the problem one, R is a region bound by the function x equal to minus square root 4y, and then line y equal to 1, and then y-axis. So we first get the area R, like actually I should I just grab a sign, and then we obtain that the pink function over here is just the parabola, right? But we stick to be the minus part. So this one should be the parabola with the vertex 0, 0 over here, but we only draw at the minus sign, which is over here. So the function should be like this. Okay, and the line y equal to 1 should be over here. Y equal to 1. And then about the y-axis. So the area of the rotation, the area R is here. We rotate about y equal to 1, so we will get the disc like this. So you may like sketch your disc, and then you can find the radius easily. So the radius over here should be the function from here to here. So you may start with the volume with respect to the variable x, right? Because the thickness of the disk is delta x. So you know that you may have to find the radius function in terms of the variable x. So you start with pi over here, and then you will put the r square here. So the r square should be the function in terms of x because we are integrating with the variable x. So we have to use the form of y equal to x squared over 4. So I will put x squared over 4, but if you just put x squared over 4, it may be wrong because the segment of the orange is just y minus x squared over 4. So why is that? Because this segment is of length 1, right? But this segment is of length x squared over 4. So if you really want the segment orange, it should be 1 minus x squared over 4. So this one is our radius, which is 1 minus x squared over 4. Okay, so next we would like to find the boundary of the intersection. So we have to find the intersection point. The intersection point is just the point where y equal to 1 and x equal to minus square root 4y. So I will put y equal to 1 and then we get x equal to minus 2. So this one should be minus 2 to 0. Okay, next we just calculate, but this problem tell that I don't have to evaluate the integral, so I will leave it like this, and this is the answer. Is there any question? Okay, so
Could I see example 1 real quick? I missed it.
example 1 over here.
Yes.
Okay,
Okay, I got the image. Thank you.
okay. For the problem 2, we firstly get the region R. So our region R is bound by the line y equal to x, right? So y equal to x should be like this. And then y equal to 2x minus 4, 2x minus 4 with the y-intercept minus 4, and then intercept 2 should be like this. Okay, and then the x-axis. So the area of the rotation is the area of the pink one. It's rotated by the y-axis. So our disk actually is our ring should be like this. So we have to do a washer method over here because it's not just a disk but a ring. So firstly, we may have to find the variable of the integral. The thickness over here is delta y, right? So we have to calculate respect to the variable y. So next, we may find the boundary of integral by solve the system of equation to find the intersection point. Okay, so we had x equal to 2x minus 4 and then x equal to 4, and then but x equal to y, so y equal to 4. So the boundary of the integral should be 0 to 4. And then we find the area of the section with the ring. So the outer radius, which is the orange one, should be x. Oh, wait. Sorry, the lower one is y equal to x, and the upper one is y equal to 2x minus 4. So the outer radius should be y equal to 2x minus 4, right? But we need the function of the variable y. So we may like isolate isolate x to be y plus 4 over 2 equal to x. So the outer so the outer radius should be y plus 4 over 2, and then square, and then minus the lower one, which is the green one, is the inner radius, which is just the x square. Sorry, the y square. Right. The orange one is the outer radius, which is this function. And the inner one over here, is just this function y equal to x. So okay, and we are done because we don't have to evaluate the integral. Okay, so is there any question so far? Okay, so we may move to more complicated problem. The question 3, the area R is bound by the two parabola, this one and this one. So we may starting by drawing the area R first. The first parabola is equal to, I may adjust the form to find the vertex so we can write it properly. I do a completing square over here is x minus 4 square, right? And then we get the function y equal to 1 over 2 x minus 4 and then square. So the first parabola is with the vertex minus 4 and then 0. And then it's open up parabola like this. And then the next parabola, it should be y square 4y plus 4 plus 4. Over here, I add plus 4 for the both sides of the equation so that I can group it to be the completing square like this. So the parabola is with the vertex. I should pull 6 out, and then the vertex should be 10 over 3 and then minus 2. 10 over 2 supposed to be like this. Okay, so I may have to find the intersection point first. So I may find the intersection point by solving the system of equation. Uh, so I will starting by try to solve the equation, which is y plus 2 square equal to, wait, okay, I may solve only the variable x is might be better. So let me try to adjust this equation a bit more. I will isolate y and then, so this one should be plus minus 20, and then y equal to minus 2 plus minus. Okay, so I will take this side of y and this side of y to be equal by try to solving this equation. This one should be the first equation, this one should be the second equation. Um, by adjust y and then I try to bring the value of y in terms of x to be equal. I will solve only the positive side, which is 6x minus 20. Okay, so x minus 4 square plus 2, 6x 20, and then square both sides and get 1 over 4 x minus 4 square plus 2x minus 4 square and then plus 4 and then equal to 6x minus 20. Okay, and then by try to adjust this equation, we may get 8, 4, 16, 24x, and then 80. So I will bring it to be factorized, minus 20x and then plus equal to 0. And here I can pull the minus 24, I can pull the minus 24 out. So let me change this to be x and then minus 4. So you see the common factor over here is x minus 4, right? So x minus 4 plus 8. Wait, this one should be, sorry, this one should be power 4. Cube plus x minus 4 and then minus 20. Okay, then and I will try to um I will try to factorize this term by using the long division. So I may take a to be x minus 4. So this one should be the equation a cube plus 8a minus 24 equal to 0. And then I use a long division to find the factor. So I may divide by 2 and then I bring the coefficient to be here 1, 0, 8 minus 24. So by doing the division, I get 2, 2, 4, 12, 24, and then 0. So the result should be a minus 2 and then a square plus 2a plus 12. So I will put the factor here to be written in the form x by 4. So the first bracket should be x minus 4 and then minus 2, right over here. And then the another one should be the green one, which is the x minus 4 square plus 2x minus 4 and then plus 12 and then equal to 0. So by using the discriminant or completing square or whatever, you may see that this term cannot be 0 because it can be rewritten at the a plus 1 square and then plus 11. So it must be greater than 0. So three terms, the product of three term is 0, and then this term is must be greater than 0. So finally, the term that should be 0 is only the first factor. Oh, sorry, the first two factor. So we conclude that the intersection is 4 and then 6. So it should be like 4, 1, and then 6 again. So the function is should be look like this and this. And then this one is the area of the rotation. Okay, so in this problem we have to rotate about the x-axis, right? So our washer, our ring should be like this one. Okay, so next we will try to find the outer and inner radius. So the radius, outer radius should be the orange segment. The orange segment is that but firstly we have to find that which variable that we use to integrate for the volume. So the thickness is the delta x, right? So the volume should be integral with respect to the x variable. So I may put the x variable right here. Okay, let's continue. The x variable, so we need the function of those two parabola to be the function in terms of x. So the first one is fine, but for the second one, we have to use y equal to minus 2 and then plus 6x minus 20. The reason why I use plus instead of the minus sign is that we use the above half of the parabola, right? So we need the function with the plus sign. Okay, so now come back with the outer radius. Our outer radius is just the function, the green one function over here. And then we put the outer radius where we sorry, I will write with green one so you may not confuse. Square root 6x minus 20 and then minus 2 and then square. Okay. And then the inner radius should be the red one, right? The red one over here. And the rest one is the function 1/2 x minus 4 square. So this one should be minus 1/2 x minus 4 and then square. And then square. All right. Okay. So Next, we have calculate this term. Oh, sorry. We still need to find the boundary of the integral, right? But we deal with the variable x, so the boundary should be from 4 to 6. 4 to 6. So here, let me calculate it. Um, but because we have to deal with many examples today. So uh I may leave it at your exercise and answer should be 40 sorry 68 pi over 45. It's just a basic calculation. You have to like square and then try to integrate using the basic formula. Okay, is there any question? Okay, so I may move to the problem 4. Okay. Okay. Actually, the problem 3 and the problem 4 use the same function, right? But we just change the axis of rotation. So I may like copy copy the function, the graph of function here to be here. Okay, but then we have to find the radius due to the changing of the axis of rotation. So I may remove some here. Okay. So the axis of rotation is x equal to 2, right? So our disk should be like this. Okay. So for now, our thickness of the disk should be the delta y. So we have to set the calculation to be respect with the variable y over here. So the boundary of the calculation, it should be 0 to where I have to find the value of the y when x equal to 6. When x equal to 6, when x equal to 4, y is 0. So when x equal to 6, when x equal to 6, y is 2y 6 squared 6, and then okay, equal to 4. 4 and then divided by 2 is equal to 4. So the boundary should be 0 to 2. So for the inner and outer radius, you have to like consider determine it carefully. So the outer radius 1 is over here, and the orange one should be the function should be written in the term of y, right? Because we change the variable of integral. So I may rewrite the formula of the parabola a little bit. So the first one should be in terms of y. So 2y equal to x minus 4 squared, and then square root 2y equal to x minus 4. And then our x equal to 4, and then we use the uh right part of the parabola, so I may use the side plus over here, square root 2y. Okay, so the radius of the outer should be the function 4 plus square root 2y and then minus 2, right? Because from here to here is 4 plus 2y, and then we minus here, which is 2. So the outer radius should be 4 plus 2y, square root 2y, and then minus 2. So I will put the outer radius as square root 2y, and then plus 4 plus 2 is plus 2 square. And for the inner radius over here, it should be this parabola, the value in terms of y of this parabola, and then minus 2 again. So I have to rewrite the function as y squared plus 4y plus 24 equal to 6x, and then x equal to 1 over 6 y squared plus 2 over 3y, and then plus 4. So the red segment should be 1 over 6 y squared plus 2 over 3y, and then plus 4, and then minus 2. Y should be minus 2 because the parabola value over here is like this term, right? But we have to minus 2 because we have to minus the distance between the x-axis and the radius, the axis of the rotation. So finally, we get the inner term as 1 over 6 y squared plus 2 over 3y, and then plus 4 minus 2 is equal to plus 2. Plus 2 over here, and then square. Okay. So I may leave the calculation as your exercise, and I will give the answer over here is 716 pi over 315.
So are questions like problem 3 and 4 going to be present in finals?
Um, I don't think the calculation would be complicated like this. I think it's more simpler.
Okay, so this is above finals,
I hope so. I guess so. I guess so
hopefully.
because this one is like the the past paper about like 8 years ago, it's on 9 years ago. Mm. Okay, so we move. Mike, is there any question? Okay, so we will move to the simpler one, the example 5. Um, okay, so I guess your function on the Excel might be like simple, only one parabola and one linear or two linear, something like that. So the problem 5, the area again have to get the area y equal to x is a linear with the slope 1 and intersect origin. And the another one is the parabola with the vertex 0, 0, right? So it should be like this. Y equal to y square equal to 4x. And the volume is rotation with the y-axis. So our washer, our ring should be like this. Okay, and you are integrating respect with the value y. So firstly, you have to find the value of y of the intersection point. So we first calculate the system y squared equal to 4x and then y equal to x. Because we only need the value of y, so I may try to isolate the value of x and then I will solve it by bring the term of y to be equal. And then we have y squared over 4 equal to y. So y squared equal to 4y and then y squared minus 4y equal to 0, which means y equal to 0 or 4. So 0 is over here and 4 is over here. Okay, so the boundary of the integral should be from 0 to 4, and then we calculate respect the value of y. So let's work about the outer and inner radius. The outer radius should be y, right? Over here. And then the inner radius should be the value of the parabola. Uh, so we need the function in terms of y. So I will isolate the x to be square over 4. So the inner radius is y square over 4. Okay, so combine, we have the outer radius to be y, and then outer radius square to be y square, and then minus the inner radius y square over 4, and then square. Okay, so we just calculate it. 4 y 4 16 1 3 y cube 185, which is point 1 3 minus 4 right. Mm, mm, mm. And the final answer should be 128 pi over 15. Okay, is there any question? I guess it might look like this, like not too simple, but not too hard. Okay, so next for the problem 6, we deal with the two parabola again. Um, the first one, y equal to x squared, is a parabola with the vertex 0, 0, right? And it's upward. Y equal to the x squared. And the next one is x equal to the y squared. It's also the parabola at the vertex 0, 0 over here. So the region should be here, and then we rotate about the x equal to -1, equal to -1 here. So our ring should be like this. So the variable of the integral is the variable y. So we need to find the boundary of the integral by doing intersection point in terms of y. So we first find the intersection point by solving the system of these two equations. So as we forgot of the variable of y, so I may sub 2 into the equation 1. So we get y equal to y squared and square. Okay, so y equal to y power 4 minus y equal to 0, and then y cubed minus 1 equal to 0. So y minus 1, y squared, y plus 1 equal to 0. And this term is always greater than 0, right? So finally, we get y equal to 0 or y equal to 1. So our volume with respect to the value of y start from y equal to 0 to y equal to 1. And now we need to determine the value of the outer radius and the inner radius again. For the outer radius, it should be value of the function y equal to the x squared, right? But now we need the function in terms of y, so I may isolate x as the square root x equal to, square root y plus or minus square root y equal to x, right? But we are dealing with the with the right part, so I may use the plus sign over here. So the radius is just the value of square root y and then minus 1, right? You may see that you may just think about the value of the square root y and then plus 1. Y plus 1, you may see that this one is square root y, right? And then we have to plus 1 because of we extend the radius from the value of the minus 1, from the axis of the x equal to minus 1. So with the summation, we have square root y and then plus 1 over here. Okay, so the outer radius is the function square root y and then plus 1 square. And for the inner radius, it should be the function from to here, which is the y square and then also plus 1, right? Because from the y-axis to this curve is y square, and then you have to plus 1 because the radius extend is a center as the x equal to minus 1 over here. So finally, the inner radius should be y square and then plus 1 and then square. Okay, so we are done. So next you may have to calculate it properly. Like y plus 2y plus 1 minus y 4 cube 1 and then dy. Okay, so should be pi 1 over 2y squared plus y 2 4 3, right? y 5 2 or 3y cube and then y and then take it from 0 to 1. So here is cancel. Okay, so the final answer should be 29 over 30 pi. Okay, is there any question? Okay, so we move to the final example of the digression methods with the problem 7. The problem 7, the curve is a polynomial of degree 3. I have to find the x-intercept of the function so that we can graph it properly. I will factor it as x times by 4 minus x squared. So it should be 2 minus x and then 2 plus x. So the x-intercept is 0, right? It's 2, 0, 0, and then 2, 0, and then minus 2, and then 0. And as the coefficient of the cube of x is negative, so the graph should be like this. Okay, so the region that enclosed by this curve and then y equal to 0, and then from x to 0, from 0 to 2 is this region. So we will rotate the region with the x-axis. So our disk should be like this. Okay, so now we are dealing with the integral respect to the function of x, right? So we have the integral with respect to x, and then this one is not a ring but a disk, a normal one. So we have pi and then times by r square, but r square we need to be in terms of x. So we put 4x minus x cube and then square at the r square. So, and then we take the boundary of the integral to be 0 to 2. Okay, and then you just do a simple calculation. You have to have it been pi down, and then 16 x squared 4 x cube and then dx. 16 3 8 over 5 over 7. Um, and then for the basic calculation, you get 1, 2, 1, 0, 2, 4 pi and then over 5. 1 over 5. Okay. Um, so is there any question with the this and washer method? Okay, so if there is no question, then we move to the another section. Okay, so the another section is the volume by cylindrical shell method. The concept of this method is like instead of you just cutting it at a dish or is as a ring, you like try to peel the shell out, to peel the shell off. Like you have the shell like this, like this, to be but layer by layer, and then you when you peel out, you get the you get the rectangle, but the rectangle is about formula is just look like the surface area of the cylinder. When you cut it and then you straight it out, you get the rectangle. But this rectangle is of the length 2 pi r, right? I mean, when r is when your radius is x, the length should be 2 pi x, as it's the circumference of the circle over here. And then the height is a function of the fx over here, which is the value of y. So you get the rectangle with the length 2 pi x, with the width fx, and then the thickness is delta x. So for the volume of one pu is like 2 pi x times by delta x. So you do this for layer by layer from the interval of A to B. You have the summation of the volume of the small rectangle. So you had summation of the 2 pi xi and then delta xi, where the xi is just the middle of each interval. So if you do like n layer, you have the volume um, of the summation from I equal to 1 and then n. And next, we will try to reduce the error of each layer over here by taking the limit n to be infinity. So the volume should be the limit, and then the summation combined as the integral, the 2 pi x over here, and then okay, I forgot to put the function fx here as the height of the cylinder. So the function is that 2 pi x as a radius and fx as the height, and then dx, right? And then you take the interval from x equal to a and then x equal to b. But basically, I just want you to remember is at the integral of 2 pi r h and then dx. 2 pi r h over here is just the formula of the surface area of the cylinder, like the lateral surface area of the cylinder, right? 2 pi rh. And then you just take the boundary of the integral over here and you change the radius to be the variable you would like to integral for. Like you use the variable x to be integrated. You use radius to be r, but sorry, you use radius to be x, and then you use the fx, which is the function of y, to be the height, and that's all. Okay, so this one is the main concept, the volume by cylindrical shell method. It's like you peel out and then you get the rectangle. Okay, so go with the formula. But if our formula is much more complicated than just only one function and the x-axis, you may uh you may compute the value of the integral by the area of two functions. Like if you rotate the area of the two function, you have to define the radius and the height carefully. Like if I say that the lower one is y equal to gx and the upper one is y equal to fx. And then if we rotate this area of the x-axis, you may firstly try to find your cylindrical like this. Okay, so your cylindrical look like this, right? So the radius should be the value of x and the height should be the difference between two functions. So you just put the upper one minus the lower one. So the upper one is fx, the lower one is gx. So for combine, you just have the volume of the um rotation by put 2 pi and then sub r with the x and then sub the height with the difference of the function. And then you put the boundary of the integral from a equal to b and then we are done. Similarly, with the rotation about the x-axis, you may just have to change the variable to be in terms of y and then change the boundary to be the boundary of y, and that's all. Okay, so we move to the example to see the picture clearly. Find the volume of the solid obtained by rotating about x-axis, and then the boundary is the function 2x squared minus cube, and then y equal to 0. So we have to like rotate this area with the y-axis. So you have your cylinder look like this, right? So we just have to find the volume with respect to the variable x. Because the thickness of the cylinder is variable x, so you need the variable x to be the variable of integral. Okay, so the boundary should be 0, 2, and then you put 2 pi, and then you need to find the radius and the height of the cylinder. The radius is a variable x, right? And the height is a variable y, but your y is equal to 2x squared minus x cubed. So you put x over here as the radius, and then y over here as the height.
So the question says rotate by the x-axis, but the diagram shows rotating by the y-axis. Is that what's happening?
Oh, wait. Um, yeah, you were right. Uh, okay, so can we just like change over here? Sorry, I may type it wrong. Okay, so now we have to like do a basic computation, and we make it 2 pi out and then 2 over 4x4 1 over 5 x 5. And we make it 16 pi over 5. Okay, so is there any question? Okay, so we move to the next one is the area with the two function at its boundary. So we write the shell, the cylinder shell like this, and then we may put the variable of the integration at the variable x, right? And the boundary of the integral should be computed by the intersection point. So firstly, I have to find the intersection point y equal to x at the first equation and y equal to x squared at the second equation. And then we get x squared equal to x, which means x times by x minus 1 equal to 0. And then x equal to 0 and 1. So the boundary of the integral should be 0 to 1. And next, we just find our radius and the height. We put 2 pi, and then the radius of the cylinder should be x, right? And then the height of the cylinder should be the upper function, which is x, minus with the lower function, which is x squared. So the radius is x, and the height is x minus x squared. Okay, so we do a simple calculation. And then x4 2.103 and the final answer is pi over 4. No, pi over 6. Okay. Okay. Is there any question so far? Okay, so we move to the exercise. The problem one actually is just the same shape, the same curve at the example on the last section. So over here we get the parabola in the negative side. X equal to minus root 4y, and then line y equal to 1 over here. So the area of the rotation is over here. So we rotate about the line y equal to 1, right? So our cylindrical may look like this. Okay, so the radius, so yeah, should be set the integral first. We may integrate using the variable y, right? Because the thickness of our cylindrical is the variable y. So we will do the integral respect to y, and then the boundary of y is just 0 to 1. And next we have to find our radius and the height to put in the formula. The radius, it should be 1 and then minus y. Be careful over here because the radius is not y but 1 minus y. So why is that? Because when you have the value of y over here and 1 over here, right? The radius is here. Like you have to bring 1 minus y to be your radius, which is the orange segment over here. So the radius is 1 minus y. And height of um the height of the cylinder is segment, the red segment here, which is 0 minus and then minus. Why is that? It's like you need to find the length over here, right? So you will bring the x of the right hand side minus the x of the left hand side. So it should be 0 minus and then minus the x at the left hand side as the minus square root 4y. Or you can see it more simpler as the function of 4y over here. Sorry, square root 4y. Okay, all right. So is there any question? Remember that your height is always positive, right? So it's not supposed to be minus square root 4y, but only square root 4y instead. Okay. So we're done with the calculation. So we're done with the setting. Next, we have to find the calculation. So, for square root y dy, and then I will pull the constant out for pi 1 minus y square root 1 dy. Okay.
Sir, doesn't it say to not evaluate the integral?
Yeah. You're right. Okay. So is there any question? Okay. Okay. Thank you for reminding me, by the way. For the next one, again, we have to draw our region first. Bound by the y equal to x. Actually, the picture is the same as the example in the last section. So y equal to x over here, and then 2 minus 4. And then x-axis. And then rotate about y-axis. And then you firstly draw your cylindrical shell. Like if you draw the cylindrical here, height should be the function y equal to x, right? But when you draw the cylinder here, if you want to do if we want to calculate the volume of the rotation of this area using the cylindrical shell method, you have to separate the volume to be two integral, like at a orange interval. So we firstly find the intersection point, which is 4 and then 4. by just solving the system of equation, you will get 4 as an intersection point. So for the first integral, you have to use the function y equal to x as a height, which is different from the second integral. Like, let me change the color a little bit. The purple one and then the pink one. So the purple one is that you integrate with respect to x, right? The boundary should be 0 to 2, and then you put 2 pi, and then find your radius and the height. And the radius of the green cylinder is x, and the height is also x. So we put x as a radius 1 and x at the height over here. Radius, height, and then plus the volume of the rotation of the area pink one, the pink area. So the boundary should be from 2 to 4, and then 2 and the radius of the cylinder is x, but the height should be x, and then minus the lower function, and the lower function is y equal to 2x minus 4. So the radius should be x, and then minus 2x minus 4, which is x minus x plus 4. So the radius over here is x, the height is minus x plus 4. Okay, the integral here is from the pink area, and the integral here is from the purple area. Okay, so we move to the next question. The region is bound by function the inequality, but we just need to find the boundary first. Its boundary should be y equal to x over e, right? It's just the linear function with the slope 1 over e. So it should be like this. The linear function y equal to x over e. And next one, I will first draw the boundary. The boundary is the exponential function which the base 1 over e. So it's a decreasing function, and the y-intercept is 0, 1, and then it may look like this. And this is area of rotation. And it rotates about y-axis. So our shell look like this. Okay, so we will find the integral using the variable y. So the boundary of the integral is from 0 to 1, and then we put 2 I, and then we find the radius and the height. The radius is, oh, sorry, we should put the, sorry, am I wrong? We should use the variable x, right? Because the thickness of the cylindrical is the x. So I have to choose the variable x to be the variable of integral. So we may have to find the intersection point first to be the boundary of the integral. So I may set the system y equal to e power x at the first example, first equation, and y equal to 1 over e power x at the second example. So x equal to e is equal to 1 e power x. So you may see that if we put x equal to 1, um, this will make the equation true, right? Because 1 over e is equal to 1 over e power 1. So this point should be 1. So the boundary of the integral is 0 to 1. Okay. So the radius of the cylinder is the value of x, and the height of the cylinder is the upper function minus the lower function. And the upper function is e power minus x minus the lower function is over. So we put x as a radius and e power minus x over e as the height. The radius 1 and the height. Okay, so next we will calculate the integral. Minus x squared over e dx. Okay, by calculating over here, you may need to use the technique of the integral x e minus x dx, x e over x squared over e dx. So the first term and the second term. With the first term, you may use by part, right? So we let du as a dx, and then v equal to minus e power minus x. So the integral of 0 to 1 x e minus x dx u v minus the integral of v du by using by part. So this should be minus x e minus x, and then minus e minus x from 0 to 1, which is 1 minus 1 over e. So the second integral is just one over e, 1 over 3 x cubed, which is 1 over 3e. So we combine the orange and the green one to be our answer, and we get 1 minus 1 over e, right? Oh, sorry, there should be 2 over e. So we get 1 minus 2 over e. And then minus 1 over 3e. Okay, so the final answer is 2 pi minus 14 over 3e pi. Okay. Is there any question? All right, so we move to the next problem. Okay. So for the problem 4, we first get the area. And the equation of the curve is the circle with the center 0, 1, right? 0 and then 1, and then the radius is 1. So it looks like this. 0, 1. So rotation is about x-axis. Cylinder look like this. Integral is about with respect to the variable y, right? So we need the function to be in terms of y. So x squared minus plus 1 square equal to 1. y minus 1 square equal to 1 minus x square, and then plus minus 1 minus x square, and then y equal to 1 plus minus y equal to 1 plus minus square root 1 minus x square. So the integral of the volume is y equal to we equal to the integral of the 2 pi, and then we try to put the radius and the height, right, with respect to the variable y. So the radius of the cylinder is just the value of y. So we put y here at the radius. And for the height, you may see that the height over here is you have to of the left hand side of the circle, and then minus the function of the you need function of the right hand side of the circle, minus the function of the left hand side of the circle. So the radius over here, so the height over here, 1 minus x, and then minus 1 minus square root 1 minus x square, right? Because the right hand side is the y with the plus sign, and the left hand side is the function y with the minus sign. So wait, but we need the function of yนี่นะ Sorry, let me do it again quickly. Sorry, we need the function of y. So we had to isolate function of x. So we need to isolate x. 1 minus y minus 1 square, and then x equal to plus minus y minus 1 square. So the left hand side should be square root 1 y minus 1 square minus square root 1 minus 1 square. Okay, this is because the purple one, the left hand side, is x equal to plus sign, and the right hand side is x equal to the minus sign. Okay, so totally we had the height equal to 2 square root 1 minus y minus 1 square. So the height over here should be 2 square root 1 minus y minus 1 square. Okay. And the boundary of the integral should be the value of y, right? So it should be 0 to 2. So next you need the basic calculation. I may put the constant out 4 pi to 2, and then y, and then y minus square, and then dy. Okay, and next I will use the u substitution by putting u 1. And then our y is u plus 1. I, our u is minus 1. Our u is 1. So the integral in terms of u should be minus 1 to 1, and then u plus 1, then square root 1 minus u square, and then du. Then we separate the integral to be two terms, u times by square root u minus u square du plus minus 1, 1 square root 1 u square, and then du. So you may see that this term is the odd function. And when the odd function with the boundary negative to the positive of 1 is just 0, right? Because the function is odd. So the first term will be 0. And then for the second term, this one is the area of the circle, the area of the upper circle. Like if you draw it, it would be the function of the upper half of the circle of center 0, 0, and radius 1, right? So this integral represents the area of the upper half of the circle of the radius 1. So it should be pi over 2. So for combining, we have the final result 2 pi square. Okay. Is there any question? I guess this one might be like harder than your exam, I guess. Okay, if that is no question, I may move to the two last problem. Okay, so for the problem 5, we first get the area. The first one is the parabola with the vertex 0, 0. Y square equal to x 0, 0 as the vertex. And the second one is the linear function y equal to x over 2. Okay. So the area of the rotation is the pink one, and we rotate up the y-axis. So our cylinder shell look like this. So we need to find the volume with respect to the variable x. We put 2 pi over here, and the radius is x, and the height is the upper function minus the lower function. But we do need the function in terms of x, right? So I will adjust the equation as as y equal to x over 2 for the first one, and then y equal to plus minus x. Actually, it should be plus minus square root x, right? But we use the upper term, the upper curve of the parabola, so I may just use the plus sign over here. Okay, so the radius is x, and the height is x over 2. Oh, sorry, it should be the upper one is square root x, right? And the lower one is x over 2. Okay, radius and then height. And the boundary of the integral, you have to find the intersection point. So I will try to solve the system. And because we only need the value of x, so I may replace the variable y with y equal to x over 2, right? We sub 2 in 1, we get x over 2 square equal to x. So x square equal to x. So x square equal to 4x. X minus 4 equal to 0. And then x equal to 0 to 4. And the boundary of the integral should be 0 to 4. Okay, and you just use the simple calculation x 3, x squared 2, and then dx 2 over 5, x 5 over 2, 1, 6, x cubed from 0 to 4. And the final answer should be 64 over 15 pi. Okay, so is there any question for the problem 5? Okay. So we move to our last problem. We first get the region, one parabola, and then one linear. The parabola here, I will try to do a complete square so we get the vertex. We will write 1 plus y plus 1 square, and then minus 1. Y square plus 2y. I will put plus 1 and then minus 1, and then I group the first 3 terms as y plus 1 square and then minus 1. So finally we get y plus 1 square equal to the x plus 1. So the vertex of the parabola should be minus 1, minus 1, minus 1, minus 1 like this. And then when x equal to 0, y equal to 0, right? So it like this. Okay, and we should write more parabola. And the another equation is a equal to y. It's just a linear function. Okay, so the intersection point should be -1 and 0. And this is the area of the rotation. For this problem, we have to rotate about y equal to 2. Y equal to 2 is the horizontal line over here. Y equal to 2. And then you have to be careful with the radius and the height of the cylinder. Your cylinder should look like this. So the thickness is delta y, right? So we have to set the calculation of integral respect to variable y. So the boundary of the integral is from -1 to 0. And then you need to find the radius and the height carefully. The radius should be the orange segment. The orange segment is 2 minus y. So why is that? Because you need the um distance between 2 and this curve, right? So you need 2 and then minus y to be the radius. And then 2 minus y are the radius. And for the height of the cylinder, you need the function uh the red segment. And the red segment, the right hand side, the right hand side is the function y equal to x. So you put y here because you need the variable of y, right? And minus the left function. The left function is the parabola. The parabola, again, you need the variable of y. So you may just use the um, formula with because it already is the so finally you get the height in terms of y as minus y squared. So we put height here. Okay, so we are set, and then we just compute it directly. Um, minus 2y squared minus 2y plus y cubed plus y squared, and then dy. So, you just use a simple calculation, and the final answer should be 5/6 and then pi. Okay. So is there any question? Okay. So if there is no question, I may like put the handout on the MyCourseView, so you may like follow after if you cannot follow one of the problem. Okay,
So
thank you guys. Oh, okay.
I
Mm.
I don't really understand the concept of both methods.
Concept of what?
Of both methods.
Really? The first one is like you try to section the volume, and then it's from the basic concept from your high school. And when your high
I,
school, mm,
I meant as in like how do you get the how to fill out the equation with the proper value.